Welcome back to the deep dive. Today we are looking at a stack of documentation that addresses a very specific, very painful kind of heartbreak.
Oh, I know exactly where you're going with this.
Right. I'm talking about the Wednesday morning panic.
The absolute worst.
You spend a week building a data pipeline, and it's beautiful, it's humming along perfectly. You go to sleep, and you wake up to just a wall of red text in your terminal.
The dreaded element not found exception. Literally the bane of my existence.
Exactly. You check the website you were scraping, and it turns out the front-end developer decided to move a Buy Now button like 3 pixels to the left.
Or they changed a CSS class from, BTN primary to BTN main.
Yeah. And your entire operation just evaporates.
It really highlights the fundamental fragility of the internet, or at least how we interact with it programmatically. We try to build these rigid structures on top of a foundation that is inherently fluid.
Constantly shifting.
Right. It's like trying to build a house on a sand dune while the wind is blowing.
But the tool we're breaking down today claims it can actually handle that shifting sand. We're talking about Scrapling.
Scrapling.
Yeah. It's an open source Python framework created by a developer named Karim Shoer. Goes by D4Vinci online. And looking at the numbers from our sources,
Impressive.
very. Over 13,000 stars on GitHub.
Yeah, 13.7 thousand, I think.
Right, and over 900 forks. So this isn't just another niche library. People are actually adopting this. The community is swapping out their old tools.
It's definitely striking a nerve. And I think the reason is that Scrapling pitches itself as this sort of zero compromises solution. Usually in the scraping world, you have a pretty strict binary choice.
You have to pick your poison.
Exactly. You either grab a lightweight library like BeautifulSoup, which is fast, but frankly pretty dumb. I mean, it breaks if the HTML changes even slightly.
Right.
Or you grab a heavy browser automator, something like Selenium or Playwright, which is smart, but it's incredibly slow and eats up all your server's RAM.
So you either get a scalpel or a sledgehammer. There's no in-between.
Exactly. But Scrapling is trying to be both. The core promise here, our mission for this deep dive really, is to explore how it adapts. It claims to handle everything from a single lightweight HTTP request to a full-scale million-page crawl.
And the feature that really caught my eye, the one that directly addresses that Wednesday morning panic we started with, is what they call smart element tracking.
Yes, the adaptive brain of the whole thing.
Let's dig into that, because smart element tracking sounds great on a marketing landing page, but how does a Python script actually know where data went if the map changes?
Right, because logic dictates it should just crash.
Exactly. If I tell it to look for a specific div and that div is gone, it should fail?
Traditionally, yes, because we use rigid selectors,
Wow.
XPath or CSS. It's like giving someone directions based purely on landmarks.
Like turn left at the big red oak tree.
Exactly. And if the city chops down the tree, you're hopelessly lost. Scrapling changes that mental model. It uses what the documentation calls intelligent similarity algorithms.
So it's not just memorizing the address.
No, it's memorizing the characteristics of the house. If the page structure updates, maybe a table becomes a list or the ID changes, Scrapling's parser analyzes the new layout on the fly.
Really?
Yeah. It looks for an element that is statistically similar to what you were originally targeting. It effectively relocates the data for you automatically.
That sounds incredibly useful, but my immediate thought as a developer is performance. If the script has to stop and basically think about where the element went every single time a page loads, doesn't that just grind everything to a halt?
You would definitely think so. But the benchmarks provided in the source material are actually really surprising. They compared Scrapling against a tool called AutoScraper, which is another library that attempts this kind of heuristic matching.
Okay, and how did it do?
Scrapling was about 5 times faster at the adaptive recognition.
5 times? That's
Yeah.
a massive difference.
Yes. The implication there is that the underlying algorithm is highly optimized. It's fast enough that you can leave it running in production without constantly worrying that your smart scraper is going to time out your server.
So it buys you resilience.
Exactly. It doesn't mean you'll literally never have to update your code again, but it handles those minor cosmetic front-end shifts that usually cause, I'd say, 90% of the breaks.
Okay, so we've got a brain that can find data even when it hides, but finding the data is really only half the battle. The other half, and arguably the harder half these days, is getting the website to actually talk to you in the first place.
The access problem, the cat and mouse game.
Yeah, because the internet isn't the Wild West anymore. We have sophisticated anti-bot protections everywhere. Cloudflare, Akamai, TLS fingerprinting. If I write a basic Python script right now and try to hit a modern e-commerce site, I am getting a 403 forbidden error before I even see a single HTML tag.
And this is where Scrapling shifts from being just a parser to being a full-on stealth framework. It separates the fetching, the actual act of downloading the page, into different classes. And the star of the show here is the stealthy fetcher.
So what makes it so stealthy? Is it just rotating user agents? Because, I mean, most libraries do that.
Well, it goes way deeper than user agents. When a standard Python script asks for a web page, it basically screams, "I am a robot," at the network level.
Right.
The way it shakes hands with the server, the TLS handshake,
Yeah.
is fundamentally different from how Chrome or Firefox does it. Security systems verify that handshake. If it doesn't match a known browser, you are instantly blocked.
So Scrapling is spoofing the handshake itself.
Exactly. The stealthy fetcher mimics the TLS fingerprints of a real human-operated browser. It matches the cipher suites, the extensions, the headers of a legitimate user. It's impersonating a human environment at the cryptographic level.
The documentation actually makes a pretty bold claim regarding Cloudflare specifically.
It does. It explicitly states, Scrapling can bypass all types of Cloudflare's turnstile and interstitial pages out of the box using automation.
That's significant. I mean, Cloudflare Turnstile is that little box that pops up and says, verify you are human. Usually, you need to route through a third-party solving service where you're paying per captcha just to get past that.
Right. The fact that this is integrated out of the box implies Scrapling is doing some very heavy lifting behind the scenes. It's convincing those security checks that the request is coming from a genuine biological entity, or at least a simulation, so convincing the algorithm can't tell the difference.
But there's a trade-off usually.
Right.
If you want to bypass these checks, or if you need to load a website that's just a giant brick of JavaScript, the modern web, where nothing actually renders until you scroll, you usually need to spin up a full browser engine.
Which absolutely kills your performance.
Yeah, Chrome is a massive resource hog. If I'm scraping 1,000 pages, I can't have 1,000 invisible Chrome instances open on my MacBook.
And Scrapling acknowledges that tension. They have a dynamic fetcher class that integrates with Playwright or Google Chrome to handle that heavy rendering. But, and this is the really smart part, they added a feature specifically to mitigate that resource drain. They call it domain blocking.
Okay, how does domain blocking help in this context?
Think about what happens when you load a modern news site as a user. You want the article text, which is, what, maybe 5 kilobytes of data?
Barely anything.
Right, but to get it, the browser downloads 4 megabytes of video ads, tracking pixels, third-party analytics scripts, high-res banner images.
All the stuff I absolutely do not want.
Exactly. The domain blocking allows you to tell the fetcher, look, load the page, execute the JavaScript so I can get the core data, but block all requests to ad networks. Block the tracking domains. Block the heavy media servers.
Oh, wow. So it's effectively running an enterprise-grade ad blocker inside the scraper.
That's exactly what it is. It saves bandwidth, it dramatically speeds up the page load, and critically, it reduces the CPU usage on your machine. It turns a heavy browser request into something much, much more manageable.
Let's zoom out a bit, because we've been talking a lot about fetching a single page, but the tagline we mentioned earlier talked about a full-scale crawl.
Right.
If I need to map out an entire domain, say 50,000 product pages on an online store, how does Scrapling handle the orchestration of that? Because writing a simple for loop in Python isn't going to cut it for that kind of scale.
No, definitely not. And this is where we move from Scrapling the library to Scrapling the framework. If you're listening and you've used Scrapy before, which has been the gold standard in Python for, I don't know, a decade.
At least a decade.
Yeah. If you know Scrapy, Scrapling's Spider API is going to look very familiar to you.
I noticed that in the docs, actually. The code samples show things like start trolls and asynchronous parse callbacks. It looks like they intentionally mirrored the Scrapy structure.
They absolutely did. They want to make the migration path as easy as possible for veteran developers. But they've added what I would call major quality of life improvements that Scrapy has historically struggled with. And the big one for me, and this ties right back to that Wednesday morning panic, is pause and resume.
Okay, explain why that matters. Because to a non-developer listener, pause just sounds like a basic button on a TV remote.
Right. In the scraping world, it is incredibly rare to get this right. Imagine you are scraping those 50,000 products. You are 90% done. The script isn't running for 12 hours straight.
Okay.
Suddenly, your internet flickers. Or you need to restart your computer for a system update. In a lot of older tools, that process is completely all or nothing. If it stops, you lose the state. You have to start over from page 1.
That's brutal. Just soul-crushing.
It really is. But with Scrapling, the system is built to handle a shriek plus C command, which is the standard abort command in a terminal. It handles it gracefully. It doesn't just die instantly. It saves a checkpoint. It essentially records exactly which URLs it has already visited, which ones are still pending in the queue, and it dumps that entire state to a file. So the next time you run the script, it picks up exactly where it left off.
That completely takes the anxiety out of running long jobs.
It really does. And combined with that, they have something called multi-session support, which is a really brilliant architectural decision for complex sites. It allows you to mix and match your fetching strategies within a single spider.
Give me a use case for that. Why would I want to mix them?
Well, think about that e-commerce site again. The main list page, the one that just shows the grid of products, might be simple, static HTML. You can scrape that with a fast, lightweight HTTP fetcher.
Right.
But when you actually click into the details page to get the price or the reviews, maybe that specific data loads dynamically via JavaScript.
Ah, so you switch to the heavy browser just for that specific page.
Exactly. You aren't locked into using the heavy tank for the whole journey. You use the bicycle for the paved road, and you only bring out the tank for the off-road sections. It optimizes the speed of the overall crawl significantly.
That makes perfect sense. And I assume it handles the other basics of crawling at scale. Like if I'm hitting a server 50,000 times, I'm going to get my IP banned if I don't rotate it.
Yes. There's a built-in proxy rotator. You just feed it a list of proxies, and it handles the rotation automatically. You can set it to rotate on every single request, or you can have it stick to one IP for an entire section. It prevents that dreaded 429 too many requests error that shuts down so many projects.
I want to pivot to something that really stood out in the feature list because it feels very right now, and that's the MCP server.
Ah, the Model Context Protocol.
Yes, we see AI slapped on absolutely everything these days. AI-powered toasters, AI-powered socks. Is this just marketing fluff, or is there a real, tangible utility to connecting a web scraper directly to an AI model?
This is actually one of the most forward-thinking parts of the entire library. It acknowledges a massive shift in how we actually use data today. Think about AI agents like Claude or Cursor or whatever LLM you use to help you code or research.
Yeah.
They all have a context window.
Which is the hard limit on how much information they can hold in their memory at once.
Right. And you pay for that context. You pay per token. Now, if you want an AI to read a website and summarize the news for you, and you just feed it the raw HTML source code,
you're feeding it thousands of lines of div tags, inline CSS, tracking scripts, and just blank white space, all just to get to 3 paragraphs of actual news text.
it's incredibly wasteful, it costs more money, it slows the model down, and it actually confuses the AI with unnecessary noise. Scrapling's MCP integration acts as a specialized filter. It allows the AI to call Scrapling as a tool directly.
How does that work in practice?
The AI basically says, hey, get me the content of this URL. Scrapling goes out, uses its smart extraction to strip away the ads, the navigation bars, the footers, and returns only the clean, highly relevant text back to the AI.
So it's essentially a preprocessor. It compresses the web down to just the signal, completely removing the noise.
Exactly. The source material actually references a demo video where they show this in action. And the speed difference is incredibly noticeable, simply because the AI isn't choking on 2 megabytes of HTML code. It's just processing a few kilobytes of clean text.
This feels like a shift in who the actual user of the web is. Like, we aren't just building scrapers to fill relational databases anymore. We're building scrapers to be the eyes and ears for AI agents.
That is absolutely the trajectory. If you believe in a future where AI agents do our browsing for us, booking flights, doing deep research on a topic, tools like Scrapling are the literal infrastructure that makes that affordable and fast.
But let me play devil's advocate for a second here. We've talked about smart tracking, stealth browsers, AI integration. Usually, when you add all these layers of intelligence and abstraction to software, it gets bloated, it gets slow. Is Scrapling heavy?
You'd naturally think so. Smart usually means slow calculation. But the benchmarks provided in the repository are surprisingly aggressive about proving the exact opposite.
What kind of numbers are we seeing?
They ran a text extraction speed test, and they took a really nasty HTML page. We're talking 5,000 nested elements deep. That is a serious stress test.
Okay, so a worst-case scenario kind of page.
Right. Scrapling clocked in at 2.02 milliseconds.
Wait, 2 milliseconds? That's barely a blip.
For context, they compared it to BeautifulSoup 4 using the standard HTML5 lib parser, which is what almost every Python tutorial tells beginners to use. That setup took nearly 3,400 milliseconds.
Wow, 3,400 versus 2. So we're talking about a tool that is over 1,000 times faster in this scenario.
In that specific benchmark, yes. And even against Mechanical Soup, which is another popular lighter tool, Scrapling was about 700 times faster.
How is that even possible? Is it written in C or Rust under the hood?
It's a Python, but it heavily utilizes LXML, which is a C-based library. And it uses highly optimized algorithms for the tree traversal. The developer clearly focused on memory efficiency and what's called lazy loading, which means it doesn't process parts of the page until you actively ask for them.
Okay. And they mentioned JSON serialization too, right?
Yes. Turning your extracted data into JSON, which you pretty much always have to do to save it or send it somewhere, is apparently 10 times faster than the standard Python library. So, to answer your question, no, smart does not mean slow here. It seems to be built from the ground up for high-throughput environments.
That's fascinating. Let's talk about the human side of this for a minute, the developer experience. If I'm a listener who knows a little bit of Python, but I'm not a senior data engineer, can I pick this up? Or do I need a PhD in computer science to configure all this?
It actually seems very accessible. They've lowered the barrier to entry significantly. For one, there's an interactive shell.
What does that allow you to do?
Well, instead of writing a script, saving it, running it, watching it fail, going back and editing it, you just launch the shell. You load the URL right there, and you can type your selectors and see the results instantly. It allows for rapid experimentation. It's basically a sandbox.
That saves a massive amount of back and forth context switching.
Absolutely. And if you want to skip writing code entirely, they have a CLI feature. You can use it directly from your terminal. You just type scrapling extract google.com, and it spits out the data. You don't even have to open a text editor.
That's really impressive. And what about for the people who live in VS Code or PyCharm?
The entire code base is fully type-hinted. That means if you use a modern IDE, you get auto-completion and error checking as you type. It actively guides you through the process. Plus, for the DevOps crowd listening, there's a ready-made Docker image built with every single release.
So no messing around with installing obscure Chrome dependencies on your Linux server. You just pull the image and run it.
Precisely. It's what they call developer quality of life. It sounds like Cream has really tried to systematically remove every friction point that makes people hate web scraping.
Before we wrap up, we do need to touch on the practical, maybe slightly legal side of wielding a tool like this, because we're talking about a framework that is specifically designed to bypass security, impersonate humans, and scrape massive amounts of data. That is, well, that's a loaded gun.
It is. It's a very powerful tool. And DeFravinci, the creator, includes a very specific disclaimer in the source material that we should absolutely echo here. This tool is provided strictly for educational and research purposes.
Which is essentially developer code for don't get yourself sued.
Or permanently banned.
Yeah.
Look, just because Scrapling can bypass a turnstile CAPTCHA or can scrape 1,000,000 pages in an hour doesn't mean you are legally or ethically free to do so. You still need to be acutely aware of local laws, data privacy regulations like GDPR, and simple netiquette.
And the robots.txt file.
Yes, the robots.txt file. That is the universal keepout sign on a server. Scrapling gives you the power to easily jump the fence, but jumping the fence is still trespassing in many contexts. If you ignore it, don't be surprised if your IP gets blacklisted permanently.
It's the classic Spider-Man rule, right? With great power comes great responsibility.
Ideally, yes. The tool itself is neutral. How you apply it defines the outcome.
So, to summarize Scrapling for everyone listening, it's adaptive, it's remarkably fast, it handles the complex modern web effortlessly, and it's fully ready for the AI era. It really feels like a generational step forward from the fragile, easily broken scripts we were all writing 5 years ago.
It absolutely represents a shift from static scraping, treating the web like a quiet library of books, to dynamic scraping. We are increasingly treating the web like a living organism that actively fights back, and we're building tools that can negotiate with it in real time.
And that leaves us with a pretty provocative thought to chew on. If tools like Scrapling become the absolute standard, if scrapers are effectively indistinguishable from human users, what does the web look like in 5 years?
That is the big question. If 50% of the traffic on a given website is AI agents using Scrapling to read content and summarize it for users, do websites eventually just stop building visual interfaces altogether?
Oh, wow.
Right? Do we move to a machine-first web where the primary way information is consumed is via API and scraper, not a human eye looking at a screen.
A web built by machines, strictly for machines.
We might already be halfway there.
That is definitely something for you to think about the next time you ask your AI to summarize an article for you. That's it for this deep dive into Scrapling. Thanks for listening, and we'll catch you in the next one.
Happy scraping.